All right, so let's do another example. Again, this one will be kind of a picture that I draw. So let's see. So let's do a car because I can draw that. Right. So we've got a car here, and we'll use a little bit bigger numbers. So we'll say that the mass of the car is 1,000 kilograms, and we'll say that the velocity of the car, right? So we'll call that car one is equal to 5 meters per second. And it's going to hit a stationary object, so it'll just hit, like, let's say, I don't know, a small wagon or something. And the mass of the wagon, actually, it's a pretty big wagon. We'll say it's 500 kilograms. So it's half the size of the car, half the mass of the car. We'll make this easy. We'll make the initial velocity of this guy 0 meters per second, so he's at rest. So this is easy here. So the before situation, this is the before. All right? And what we do know about this situation is that the P initial, which is everything that's happening here in the before part, is going to be equal to the momentum, the total momentum after they collide together. So after they're going to be stuck together, you're going to have a car here like this, right? And you're going to have this wagon thing stuck to the front of your car, and you're going to be pushing it down the road, right? And we want to know what the final velocity is. Now, what do we know about this situation for the after part already? What do we know? Well, we know that the total mass is going to be 1,000 plus 500. So we know that M total is equal to 1,500 kilograms. We don't know the final velocity, but we do know the initial velocity, we do know the initial momentum is equal to the final momentum. So if I can get this first, right, then I just plug this number into here. So my initial momentum here is fairly easy. For this guy, it's going to be P is equal to M times V, which in this case is 1,000 multiplied by 5. So it's 5,000. And the unit is kilogram meters per second. The momentum for this guy over here is 0, right? So it's 0 kilogram meters per second. So that's easy. The total momentum of this system initially is 5,000. Now, we know that if all of the momentum is conserved, then this also becomes the after momentum when they're stuck together. So what you're going to do is now you're going to substitute it into this equation here. P initial equals P final. Well, that's easy. I'm going to say my initial momentum is 5,000 equals, and then I know that momentum final is the total mass, I'm going to put a little t right here, multiplied by the final velocity. So this is x. We have this, we have this. So we say, well, total mass is 1,500, right? And then VF is just like your final velocity. So for me, I just divide both sides by 1,500, right? So this ends up being 5,000 over 15. So 5,000 over 15 equals VF. If we simplify this, we end up with 500 divided by 15. Whoops, nope. 500 divided by 150. Actually, you can do 50 divided by 15 equals VF. Got it? If I divide both sides by 5, I end up with 10 over 3. And then 10 divided by 3 is 3.33 meters per second, roughly, if you do the math here. So anyway, if this is my final velocity, that makes sense because my initial velocity was 5. Okay? Now, I'm going to do something that's kind of difficult. And if I were to start like this, you'd probably be a little bit confused. But P initial is equal to P final. And we normally write this down as all of the objects, we're going to calculate the momentum and add them together. And then we're going to say those are equal to whatever the final momentum is. So we end up with this equation like this. The mass of the car was M1. Its velocity was M1 plus the mass of the second object, right, times the velocity of the second object has to be equal to whatever these two objects stuck together would be times their velocity. So this is the big long equation. It looks kind of ugly, but if you look back on your numbers and just stuff them in the equation, M1 we said was 1,000, right? The velocity of M1, I'll put parentheses here, was 5 plus, and then we said this guy was 500, multiplied by, well, his velocity was 0, equals, and then this was 1,500 times x, which is really just VF. I'll use VF. I like to use VF. So this is just all of the math I did here, but a little more organized. So if you were to take this equation and write it down, this is the equation we're going to use anytime two objects stick together. So this ends up being 5,000 plus this is 0. Don't make the mistake of saying, oh, okay, 500 goes here and then 0, and so it's plus 500. No, this cancels out because it cancels out. It multiplies to be 0. So this is 0 equals 1,500 times VF. So I end up with, again, 1,500, 5,000 here, and then VF here. And again, if I do my math out, I get 3.33. Now, the good thing is that if you make a mistake here, normally you're going to get an answer that doesn't make any sense. You can't hit something and end up with a speed that's higher than what you were going at. Okay, let's do one more example here using my equation, M1 V1 plus M2 V2 equals M1 plus M2 times VF. So this is before. Everything that's happening before goes into that equation. Everything after goes here. So I'll just do 2 blocks. So you got a block that's 1, and no, actually we're not going to make it 1. We'll make it 3, and its speed is 2 meters per second, and it smashes into a block over here that is 4, and it's not moving at all. So the initial is 0. This guy's velocity over here is, so we'll call this V1. We'll call this V2. This obviously is M1. I always pick the one on the left to be M1. The one on the right is M2. So they smash into each other, and I want to know what their velocity is when they're stuck together, right? So I'm not even going to draw the whole situation. This is before, and then the after situation, I will draw it. It looks like this here. So you got 3 and a 4 stuck together, and they're moving at some speed that you know has to be less than 2 because you just increased the mass by quite a bit. So if I was to take this equation and dump all of this information into that equation, I end up with this here. I'll write it again. M1V1 plus M2V2 is equal to M1 plus M2 times VF. So I take the 3 here. It's this guy. His velocity is 2, right? Plus, I'll use parentheses. I don't really like to use the dot symbol. Plus 4 multiplied by 0 equals, and then the total mass after they collide together, we're just going to say that that's 3 plus 4, right? So I'll do this, the long way, times VF. So algebraically, this is 0, so this ends up being 6 equals 7 VF. So for this here, I just divide both sides by 7. Got it? And so my answer is VF equals 6 divided by 7, whatever that comes out to. It's like point something. Okay. Any questions? All right. Why am I asking if you have questions? You can't ask questions. If you have questions, you can send me an email. But the point is that you should always, anytime you have a collision, always write this equation down, right? And it looks like this here. Whoops. And sometimes we put little symbols like this here, meaning prime symbols. You may see those symbols. Don't worry about what those mean. You'll do that in math class, and when you're a junior, you can take physics. We'll go over that. But again, this is initial momentum, initial P. This is final P. Got it? Okay. If you have any questions, again, you can shoot me an email or you can ask me in class.